as the new digital era brings new challenges. We need innovators who can find the answers to the problems of the future today. At eConsulate, we dream of tomorrow and make it a reality every day. Since launching in 2020, eConsulate has become Sri Lanka's hottest, multi-talented technological hub. Attracting passionate and high-caliber engineers to join our existing team of over 50 members who previously worked at Fortune 100 companies. Developing next-generation digital solutions that revolutionize the supply chain, education, disaster management and other industries. We help companies grow by building the next big thing. When every day brings new problems to fix, we get moving. By combining agile methodology with the best practices, we can accelerate our software development to move fast and deliver high-quality results on time, every time. Our subsidiary venture, SCM Studio, provides analytical solutions and shipping management services for multinationals to streamline their import-export processes. Our innovation hub, Xavier, focuses on developing artificially intelligent autonomous robots that can safely function in hazardous environments without human operators. These robots can solve problems in construction, manufacturing and transportation industries and be deployed into disaster management situations where humans cannot go to recover wastage and save lives. Our diverse technology stack keeps us ahead of the competition, allowing our team to rotate between projects using over 20 different programming languages and cutting-edge technology depending on their interests. We train them and mentor them to compete at international levels given our global client base. We invest in our team because we believe that they are the golden ticket to take eConsulate to new and glorious heights. eConsulate. It's where the future is happening.
Whether you are running a orchestrates data and adds capabilities to your business so you can thrive and grow. IFS.AI, award-winning asset and service management software.
So there's this place. This place is kind of interesting.
Like me next to you, and you next to me. Hello, I got places to be. Like me next to you, and you next to me. Hello, I got places to be. Like me next to you, and you next to me. And you next to me, and you next to me. And you next to me. Hello, I got places to be.
Good evening, everyone. It is truly a pleasure to welcome you all to the third workshop of Intellihack 5.0, Introduction to Large Language Models and OpenAI API. I'm Hafsa Wazir, and I'll be your moderator for this session. It's fantastic to see so many eager minds gathered here, ready to explore the fascinating world of AI-driven language models. For those who may not be familiar, the UCSC IEEE Computer Society Student Branch Chapter is a dynamic student community dedicated to fostering technological growth, facilitating network with industry experts, and honing essential skills through various initiatives. One of our flagship events is Intellihack, Sri Lanka's premium machine learning hackathon, which we are proud to host for the 5th consecutive year. So to give all of you all a brief introduction to Intellihack, so it is a pioneering machine learning hackathon designed to push the boundaries of innovation, providing undergraduate students with an opportunity to solve real-world challenges while enhancing their technical powers. Each year, we bring together top-tier mentors, industry collaborations, and cutting-edge problem statements to create an unparalleled learning experience. This year, Intellihack 5.0 promises to be even bigger and better with a series of insightful workshops, intense competition rounds, and the opportunity to collaborate with some of the brightest minds in AI and ML. To appreciate how far we've come, let's take a quick look at the evolution of Intellihack. The first 3 editions laid the groundwork for this prestigious competition, gathering talented individuals to tackle complex problems. Last year, Intellihack NextGen took things to a whole new level, introducing innovative perspectives and groundbreaking solutions. Now, let's take a brief look at Intellihack NextGen through this recap video. Hackathon of this scale would not be possible without the unwavering support of our incredible sponsors and partners. So let's introduce our gold partner, eConsulate, driving excellence in technological innovation. Our innovation partner, IFS, fostering breakthroughs and supporting creative advancements. And we're also thankful to our sponsor, Circles.life. And next on, we have our AI partner, Stanford, pioneering AI research and shaping the future of machine learning. We sincerely appreciate their valuable contributions in making Intellihack 5.0 a grand success. To help you navigate the journey, let's go over the competition timeline and upcoming workshops. The hackathon consists of 2 primary rounds. We have the initial round, in which the teams will be given 5 machine learning related questions to evaluate their domain knowledge. And then we have the final round. The top performing teams will advance to develop an ML-based application incorporating LLMs and OpenAI tools. In our last session, we explored deep learning essentials, gaining insights into neural network architectures. Building on that foundation, today's workshop will delve into LLMs and OpenAI API, equipping you with essential knowledge and hands-on experience to cutting-edge AI capabilities. So feel free to engage throughout the session. And if you all have any questions, do drop them in the meeting chat. Now to the most important part of our session. It is my absolute pleasure to introduce today's distinguished speakers. Winsuka Jivandara, AI engineer at Stanford, specializing in language model applications and generative AI research. And we have Kaveru Hapuarachi, conversation design associate at ConvoGrid AI, with expertise in human AI interaction and conversational interfaces. We are truly honored to have them with us today to share their expertise and practical insights on LLMs and the OpenAI platform. Without further ado, let's welcome our speaker, Winsuka Jivandara.
Hi. I think you can see my screen. Yes. So, hi everyone. Welcome all of you to this session on transformers and large language models. Can you hear me, guys? Yes, I think so. So, welcome all of you to this session. So, I'm Winsuka. I'm a AI engineer at Stanford. I'm also a AI and data science undergraduate at RGU, Robert Gordon University, and I have worked as a data engineer at Deloitte. So in today's workshop, it includes three main parts where I'm going to talk about the theoretical aspect of the subject, about transformers and LLMs, and I'm trying to, sorry, give me a second. Sorry guys, forgot to switch on my video. Right, now it's fine. So today's session includes three main parts where I'm going to talk about the theoretical aspect of the subject, about transformers and LLMs, and I'm trying to give you all a brief overview. And we have separate demonstration session where Kaviru, where he will go through the practical usage of this. And at last, we have a Q&A session. So these are all the topics that I'm going to cover, from language modeling to LLM fundamentals to prompting and prompt engineering and fine-tuning models for specific tasks. So let's before we dive in, a quick intro about Standard. We are a AI-focused startup. We are built upon three main pillars: intelligent solutions, digital transformations, and research-driven innovations. So if you have any interest towards any of these, don't forget to go through our careers page. We have few openings at the moment. So yeah, let's begin with language modeling. So language model. What's mean by language modeling? Here, given some sequence of words from W1 to Wn, and we are going to calculate probability, which is the probability of an entire sentence or sequence of word given by W. So we have W to show the sequence between W1 to Wn. And also, we calculate the probability of the next word given from W1 to W4. Here we calculate the probability of W5. So a model computes either of these called a language model, or we call it a LM. In the goal of LM is to assign a probability to a sentence, right? If we look at some of the applications in machine translation, if we go to machine translation, we want LLM to be able to select between good and bad translations by their probabilities. If we translate in Sinhala, oya koheda yanne to English, where are you going? So where are you going is a better translation than you were going, right? So likewise, we want LLM to be able to select between good and bad translations. If we take spell corrections, the office is about 15 minutes from my house. So there's a spelling mistake in the word minutes. So the LLM should be able to identify the correct spelling on this case, right? And again, if we take speech recognition as an example, if you pronounce I saw a van, it can be mispronounced like this. I even can't say this. So it should be able to, LMs should be able to identify I saw a van as a correct version. So that's the whole purpose of LMs. So LMs can be applied to summarizations, question answering, and etc. All right. So generative AI with LMs. LMs like Ngram models and RNN LSTMs were primarily designed for language understanding, classification, and prediction, not for generation. These are several limitations in generative AI with LMs. One is lack of creativity. These models could only predict the next word responses. They can't be creative when generating responses. Short memory. Models like RNNs and LSTMs struggle with vanishing gradient problem, where they can't remember long form context. And then sequential processing. They process text word by word. So they are very slow and inefficient in performance. At last, limited training data and parameters. So the models like LSTMs had only million parameters. So, but if we train them with more data, it can be overfit. So but like when we compare to modern LLMs, they are trained with billions and trillions of parameters, right? So usually LMs, language models, are not suitable for tasks like creative writing, code generation, or image caption, or any other example like that. Generating text with RNN. We'll take an example from RNNs. So if we give a sentence like this to RNNs to predict the next word, so this example, the cat sat on the. These are, they are, there's a possibility to give outputs like this, right? The cat sit on the tree, the cat sat on the banana, likewise. Why? RNN model remembers only the last few words. it forgets earlier context. So that's the main problem that we have to tackle or we are facing with our RNN models. So the next, generating text with RNN. So let's take a longer sentence like this. The cat sat on the soft cushion near the fireplace, purring happily as it warmed itself. If we ask the model what should come next, it will give something like, which don't make any sense, right? So because in this example, RNN might forget fireplace after a while. Yeah. So, but in 2017, a bunch of researchers from Google released a groundbreaking research called Attention is All You Need. This introduced this novel architect called transformers. Why it's revolutionary? Because of three things. No more sequential processing means it do parallelized training, right? It uses self-attention where it can focus on one important word regardless of the distance. And then it's more efficient on large scale text data. So these are the main three things that focus on this transformer architecture. If we compare pre-transformer language models and transformer-based models, there are several differences that we can discuss. So pre-transformer language models do sequential processing like word by word. It struggles with long dependencies because it has this vanishing gradient issue, and also they are hard to scale. But with transformer-based models, we can do parallelized processing to the whole sentence, not one by one. And also it includes this self-attention mechanism. It gives more weight to specific words. So, and they are highly scalable because they can handle large data sets using transformer models. And as we discussed, a key feature that transformer differs from other traditional approaches is its self-attention mechanism. So this diagram called attention map, so it shows how each word interconnected with each other word. And this connection has separate weights. That's the uniqueness of self-attention mechanism. As you can see, the word student is strongly connected with the word book. So in here, you can see a complete architecture of a transformer and also the high-level diagram of the key component of the architecture. So now let's go through this transformer architecture. Right. So at first, before passing text to the transformer, we must first tokenize the text. Tokenizing means converting a set of words to a set of chunks and then converting them again to numbers, as you can see. You can select multiple different tokenization methods, but remember, once you select a tokenizer to train a model, you have to use the same tokenizer to generate text as well. Next, we pass the tokenized input to the embedding layer. Each token ID is mapped to a corresponding high-dimensional vector in the embedding matrix. And here, each token ID is replaced by dense vector of real numbers, which represents its meaning. Embedding matrix scores these vectors, learn during the training process. And now each token is converted into dense vector to the embedding layer, but there's a problem. What's that? So transformers don't have an idea about the word order. So to resolve that issue, we do positional encoding. Positional encoding. In positional encoding, a unique vector is assigned to each position in the input sequence based on mathematical formula. So this is done using sine and cosine functions. And we are assigning a unique vector for each position in the input sequence. And then after making the vector to an order, we pass the result to self-attention layer. So self-attention mechanism allows the transformer to focus on important relevant words in a sentence while processing. So you already know about this layer now. So transformers in here, transformers look at all words at once, but give different importance or attention to each word, right? Then but single attention mechanism may not be enough, because you have to capture all the relationships in a sentence. Instead of including one self-attention score, the model computes multiple attention scores. Each attention score can be focused on different aspect of the sentence. One might focus on grammar, another might focus on meaning, and likewise. So after self-attention, each token representation is passed through a fully connected feed-forward neural network. So this helps the model to further refine the meaning of each word. Simply, it processes each token independently and strengthens the most important feature before passing them to the next layer. Yes, now we have, give me a second. So yeah, here. Now the final process tokens are able to predict the next word or classify a sentence. So the previous layer output a raw score for the next prediction of the words. The softmax layer then converts these logits into probabilities, right? That helps to identify the most suitable next word the model should predict. And now, up to this point, you have a high-level understanding of the transformer architecture, right? So now let's look at how the overall prediction process works from end to end. Let's take a translation task and see how we can use transformer model to translate a Sinhala word to English. Right. So as we discussed, the first step is tokenizing. So we tokenize the sentence into small parts. And then we map tokens. We map token IDs to each tokens. And then here. In the second step, we do encoder processing. So in encoder processing, tokens are fed into the encoder's input. They pass through the embedding layer where it converts tokens into vectors. Then go through the multi-headed attention layer for context understanding. And output is processed to a feed-forward network. So it generates a deep representation of meaning and structure. So this representation is passed to the decoder to help it understand the output. So that's how we do the encoder processing. And at next, we do the decoder process. So the decoder starts with an input token, and then self-attention layer in the decoder uses both past output and decoder representation to predict the next word. The output is processed to a feed-forward network and a softmax layer to generate a probability distribution over possible words. So yeah. And then so at next we do the generating the sentence. So here the first predicted token is fed back into the decoder as the input. This process repeats in a loop, predicting one token at a time. So it continues until an end of sequence token is predicted. At last, for the last step, we do the detokenization and final output. So the generated sequence of tokens is converted back into words. Then the final, we can get the final output, which is the translated English sentence. So up to this. So now I think you can understand how this flow works in the transform architecture. So up to this, if you have any question, you're free to ask. We'll move on to the next section. We'll talk about types of transformers. So the title should be types of transform models. Sorry for that. So as the first model, we have the encoder only model. So this you used to understand and process text input, but doesn't generate new text, right? Because there's only the encoder to learn deep contextual representations. These models usually used to tasks like classification and sentiment analysis. And at second, we have encoder-decoder models. These are models like, so the encoder-only models are like BERT. So encoder-decoder models are the ones we have already discussed. So these are the models like T5 and BART. So as we have already discussed this, so this model converts inputs text into meaningful outputs, like translation or summarization. So it uses both encoder decoder. So where encoder understands input and decoder generates the output. At last, we have the decoder only model. So these are models like GPT-3 and Llama. So these generate text based on previous words. There's no full input encoding. How? Because it uses self-attention mechanism to predict the next word. So these models are good for chatbots and content generation, and also tasks like creative writing. Now, let's discuss about model pre-training. There are common pre-training strategies we can talk about: mass language modeling, casual language modeling, sequence to sequence pre-training, and unsupervised reinforcement learning training. So at first, we'll discuss about mass language modeling method. So this method used for encoder only models like BERT, Robota. So how this works is, so some words in a sentence are hidden or masked, right? The model look at the surrounding words and then predict the missing ones. This pre-training practice is best for tasks like understanding meaning or context, and these are good for tasks like sentiment analysis, name entity recognition, and question answering, and etc. And if you go to the casual language modeling method, these are used by the decode-only models like GPT and Llama. So how it works is the model only sees previous words and predict the next word. Right? An important point is it generates text sequentially from left to right. So this pre-training practice is good for generating human-like text, and also for chatbots, storytelling, code generation, and etc. And in sequence to sequence method, it's used by encoder decoder models like T5 BART. So in here, the encoder reads and understands the input text. The decoder generates a transformed version, and it's like rewriting a text in a different form, right? So these are best for text transformation tasks like summarization, translation, rewriting, and converting one text format to another. At last, we have unsupervised reinforcement training. This is a new method used in the DeepSeek R1 model. So here, how that works is, this method does not rely on label dataset, but instead learns by interacting with an environment and improving based on rewards. So it combines reinforcement learning with unsupervised learning, and allow the model to refine output dynamically. For example, instead of training with label translations, the model experiments with output and adjusts based on the feedback. So that's all about we have to cover in the pre-training slide. Now let's move on to the prompting and prompt engineering. So LLMs, they generate text based on patterns in data. Why prompt engineering important is, it helps to structure input in a way that improves understanding, right? It's kind of a fine-tuning process. So we are discussing about three main prompting techniques. One is zero-shot prompting. How it works is, there's no example are given. The model relies purely on its pre-trained knowledge. So these are best for general knowledge tasks and straightforward queries. And in one-shot prompting, how it works is, when one example is provided to guide the model, right? So there's only one example is provided in one-shot prompting. So these can be used to slightly complex tasks, and for tasks like formatting the sensitive responses. And at last, we have few shot prompting. in here, there's multiple examples are provided to help the model to understand the task better. These are good for complex reasoning and style consistency or improved accuracy. So then we'll talk about fine tuning. So can you guess why prompt engineering alone isn't enough? Because some tasks need deeper changes, right, than just prompt engineering. Why we do fine tuning? Because pre-trained LLMs are general purpose models. Because they are trained on large scale of internet data, but may not be optimized for specific industries or tasks. And they lack domain specific knowledge. So a general LLM might not fully understand legal, medical, or financial jargons without further training. And also, one important point is prompting doesn't guarantee accuracy or consistency or compliance. But with fine tuning, we improve its relevance and accuracy to a specialized task. So we'll discuss how fine tuning works. So there are several steps. Start with the pre-trained model, because instead of training from scratch, we take existing LLM that already understands the language. In next step, we train further on domain-specific dataset. Here, we expose the model to specialized data to learn from specific language and patterns. And then we adjust weights and patterns. So the model fine-tunes its internal representation to better fit the new data, right? At last, results in more accurate and relevant responses. So fine-tuning models provide better context understanding, improved accuracy, and domain-specific expertise for specialized tasks. So this is the overview about fine-tuning and general steps that we have to undergo when we are performing fine-tuning. So I think now you all have a general idea about the fine-tuning and how it's differ from the prompt engineering. So up to this, if you have any question, you can raise. At last, in the final slide, we'll discuss about the alternative for transformers. So Mamba is a new architecture that claims to outperform transformers in certain tasks, right? It introduces a more efficient way to handle long-range dependencies in sequences. So, but for today's session, we are not going to cover this topic or go deep on this, but you can scan these QR codes and read more on this. So, yeah, that's the end of my session. Let's go to the demonstration now. And yeah, I request all of you to engage with this and actively participate in the demonstration session. So I will hand over to Kabiru to continue with the demonstration. Thank you very much. Thank you, everyone.
Thank you, Vinsuka. So, okay, so systems undergraduate at University of Colombo School of Computing, and I also do AI research for standard and also a conversational designer. I work part-time as a conversational designer and a content strategist at AI. So yeah, next slide. So here I have prepared a small repository that you can actually use. So I actually posted a video about this. If you haven't gone through it or anything, I'll start from the beginning, but you can actually clone this repository. You can let me just share the link in the chat as well. So I hope everyone at least have Python installed in laptops and machines. Okay. Okay, so this is the repository that you have to clone. Visuka, can I share the screen? Let me share my screen. Okay, I hope it's visible. Okay. So first things first. So I'm going to do this from the start. So let me see if there are any questions. So again, if you have any questions during the session, feel free to put it in the chat as well. So okay, first of all, you need to go to somewhere that you can clone this repository. So I'm going to go to downloads folder. This is where I'm going to code this. So you just have to copy code. I have made this publicly available. Git clone repository. It will just take a second. It's a very small repository. After that, you just have to go to the inside of the repository and open it with Visual Studio Code. Okay, so in this repository, there are basically few files that you are going to need. So I have the gitignore file, which has these virtual environments and all that, and sample API key, and requirements txt file. So these are the main libraries that I'm going to use during the session. Yeah, let me just get started with the virtual environment first. Okay. So first things first, you need to open a terminal again, or you can use the previous one as well. But okay, for now, can I get a raise of hand if anyone needs more time to set this up? Because it's really important that you get this initial step done and clone the repository first. If you need more time, just give me a raise of hand. I think you can do it. Okay, so I can't actually see anything. Anyone raising hands? Okay. So first of all, you have to start by setting up the virtual environment. So main reason why we are setting up these virtual environments is that when you're working with different projects, some of these projects might have different requirements basically for versions. So in here, in this one, I'm going to use Python 3.10. We can call it 3. Yeah, it's 3.10. Actually, it's the 10th iteration. So I'm going to use that one. So there might be some projects that you have to use something like 3.4, 3.9, or something like this. So with the differences, there are small differences, but when it comes to machine learning, specifically in TensorFlow, I have found some errors that you can't work with some versions of Python. So that's why you need to specify version that you're going to use. So this is actually a silly thing, but if when you are working with different projects at the same time in the same machine, then it's really important that you have different virtual environments where you are going to run this program. So as an initial step, so in the demo video, I created it using the Anaconda. So I have Anaconda installed in here, as you can see here. So if you're not using Conda, you can use simply virtual environments. Okay, so if you're using Mac OS or Linux, you just have to copy this command and paste it here, and it will create your virtual environment. So Python 3. So in Windows, you don't have to specify the tree part. You can create the virtual environment in this repository here, in the same place, in the same directory, just like that. It's been created here. So it has all the initial things that you need, and then you have to activate it. So before activating, as you can see here, the terminal is on base conda. That means it's the basic, or it's kind of the foundational level of the environment that time. Whenever I'm opening a terminal, that's the one it's running on. Then you can source venv bin activate. So that means bin. In here you have an activate file. So you are going to run that one. Okay, with that, as you can see from here, now I am using this .venv virtual environment. So the next step is to install all the dependencies. So if you have worked with Node.js or any Python, anything before, so in order to run a project, you need different dependencies or libraries. So for an example, since we are doing OpenAI, so we are definitely going to need OpenAI to do this one. And Python.env, that's a library that helps you to kind of get the local environmental variables into the setup, and also OS. Actually, you don't have to install OS, it's there. And requests is actually, so OpenAI basically handles all the requests that you are sending as a client to the OpenAI API. But I'm going to do some image generation parts as well during this demo. So to handle URLs and handle secondary level of requests, you need to install this library. And Pillow is actually, it's also a part of that image part, because it will help you to actually, once you go to here, you can see pip or project Pillow. You can see all these details inside these links. Spend some time around this repository and get to know each library, because these four are actually really important. So what I was talking about is Pillow. Pillow helps you to manipulate and show images, delete images through links and all that. Okay, so the next step is to install all those things. So you could just actually type and pip install OpenAI pip install, Python.env pip install, request pip install, Pillow. You can do that, or you can just copy paste this command where I will read the requirement txt document and install all the necessary dependencies. It will take few seconds or few minutes depending on the internet connection. So it didn't take much time in here because I have already installed it previously in my machine. Okay, so now, if you need any more time, if you need anything else or any help, you can actually raise your hand or put it in the chat. I'll give you about 30 seconds if you have any questions. Okay, so let's move forward. So now we have installed all the dependencies. So whether you are using Conda or virtual environment venv, it's the same command. So basically, yeah, now we have all the dependencies installed. So if you have actually if you have watched the demo, I created this one and to test out whether everything is working. So I'm just going to do that part again for just to get you started. So you can do it here with me. I'll push this one out. But before that, you have to do another one thing. So yeah, you need to create a new environment file. So this is the sample one. That means it's just there to get anyone else who's coming to this project to get an idea that there should be one. You need to create a .tnv project and paste this one. So this is the OpenAI API key that I'm going to use, and I'll put it in the chat as well so you can have it for today. Okay, paste this one inside your repository as the .tnv file. You can use it during the demo. Okay, so let me create a new Python book actually. So you can actually use just Python for this one, but I'm using this interactive Python because it's actually easy to demonstrate each step, and it's what you use when you are actually testing out things in a development environment. So yeah, just to so in here now, as I said, I have added venv. So you need to set the Python environment to .venv, the one that's inside this project. So yeah. For now, I'm going to import OpenAI. So now, as you can see, it's there. There's this OpenAI module, and we have the class OpenAI with all the functions that we need for this one. And also we need .tnv, and also we need OS. OS is basically to get these environment keys to the development environment. So I'm going to run this, and now here's the other one. So you need to install this one as well. When you first run this one, you can install this one. It will take about a minute. So during that time, if you have any questions, you can ask. Okay, so first of all, let's get the OpenAI key to our setup. .tnv and code.tnv. Here I'm going to just run the function, and then I'm going to create a new client. You can use whatever you want, but this is the way actually OpenAI have mentioned this in their documentation, and you can use API key. This is the same API key then that you have mentioned in the env file, get env, and in here you need to add this variable. This is the variable that we are going to refer inside here, and actually you can print this and see whether we are getting the required part. I'm just going to do that like that. Okay, so as you can see, this is same as this one. So this is basic Python. So now we are getting it. So I'm just going to remove this line. Clear outputs. So since we are in the second step, I'm going to restart this one. And I start from the beginning. Okay, now this is working. Okay, everything working fine. So when it comes to OpenAI, the first thing you need to understand is basic text generation. So what does that mean? What it means is that when you go to ChatGPT, in their web app also, they are starting a new API request with the OpenAI API backend. So in there, you have this input, the chat input part, that is the place that they define that you are a user, and you can send the content as a message to the backend. So in here also, I'm going to create this is the basic structure that you have to there are different roles that we can talk about. So in this one, I'm just going to mention it as user, and then add the content. Content as yeah, I have this one here. Let me get this. So this is actually already available in the repository, so you can test it out. Okay. Okay, so you have to create a basic message like this and send this one to see whether what it returns. So basically, since you are the client and you are the one who is sending this request, you need to define your role as the user and send whatever it is that you want to get done as the content of the message. So yeah, let's send this one. So let's send our first API request to OpenAI. So you can define it like response. Again, you can use any variable name here, but just try to name it in a way that you can actually refer to after this one. Client chat completion. So inside this function, you need to define what's the model that you're going to use. So this is actually a really important one for Intellihack as well, because you can use any model you have, but you have to be very careful how you are using and what is the model that you should be able to explain why you are using this model. So in here, I'm going to get a very small task done. So that's why I'm using GPT-4o mini. It's a really powerful model, but it's not as powerful as GPT-4o or GPT-4 Turbo. And it's very cost effective. You can go through the pricing charts and see all that. And yeah, but before any of that, let me just see whether this works. So this is not the way you should actually print this one if you want to see what's the output, but let me just run it here. Okay, so as you can see, we did get a response. Let me open it in here. So as you can see, this is a chat in chat completion, and in here we have different choices. So if you want to, this is the actual output that we need, starting from content equal this part. So this is the index 0. So as you can see, this is so now you know this is in index 0. Now you can print it out like this. Print dot choices, and this is the 0th one in message dot content. Okay, so this is the one we got as the output for the request that we sent. So this is not anything structured or anything like that. We just send the request and got an answer. We didn't mention anything for specifically for OpenAI to do here, and we just send the request, and this is what we got. So in the next step, I want to show you that we can do a little bit better than this. So in this part, I'm going to get this optimized message actually. So this one in here, let me explain. So what we did earlier was we just sent this part, user and content. So OpenAI API could have run it as any way that they want to. So basically, we didn't define any system messages. So in OpenAI chat completion, I think here you can see it. So in Playground, you can define each system messages, but by a system message, it means what that system is going to do. So this depends on the use case. I think in Vinsuga's part, he explained about how you can use these AI agents or anything like that in different use scenarios. So for an example in here, if you want a chatbot or an application that works in an area that's related to health sector, then you can mention you are a helpful assistant who works at a hospital. So when you're answering questions, you need to be careful, and like that you can define what this system should do. So that is what we are doing by setting a system role here as well. So as you can see, now I have set up I have a content setup as you are a creative and descriptive children's storyteller who craft narratives with vivid imagery of this one and beginning, middle, end. So there is a clear structure, and write a poem in that way. So yeah, let's run this one actually. So again, you can do the same thing, but just to keep this more simple, I'm going to create a new one. And then let me just hit this one as well. Now let's run this one and see how it works. So now we have clearly defined how our output should look like. Okay. Okay, the issue is here. So we used response. Let me rerun this again. Now it should work. Okay, as you can see here, now this is the output we got earlier without any structures. Now we have some structured output here. So we have a beginning and we have a middle part and an ending. So actually, yeah, I can actually explain that part here as well. So let me see whether we got any other choices for this one. Usually it won't work. Yeah, it won't work. That's okay. So now let me run this again and see how it works again. Get anything outside the initial one. That's okay. So we have a start to the poem, a little bit more structured than this one, the story. And yeah, so this is what you can do if you have access to the OpenAI API without fine tuning. So you can actually fine tune the model that you're using here, and then mention. You can fine tune with you can use Q&A pairs and fine tune the model using. You can easily fine tune it using this dashboard here. And, I think we have a few things that we have already fine-tuned in one of our different projects. So you can create a fine-tune job here and fine-tune a base model according to your need, but it's very costly. You will have to spend some money when it comes to fine-tuning. But if you can get the work done using a simple prompt, it would be much easier and much cost effective. But again, it depends on your use case as well. Okay, so in the next part, let me just yeah, we don't need this one. Okay, in the next part, I want to discuss about how other parameters works. So for an example, in here we didn't. You can actually I'll show it using this one because it's kind of easy. So in here, when it comes to configurations, you can configure the temperature of the model. You can configure the max toggle limits. So what temperature does is it actually gives you the opportunity to create more random results. So for an example, if you are for our use case, basically, our use case is to write a story. So that means we need to be more creative. So in order to be more creative, you need to set your model temperature to a higher value. So you can do that by just passing one parameter. So in here, you just have to pass. Let's run this one again. And we don't need this one for now. Okay, nice. So now I'm going to create another response. I'm going to make this high temp, maybe. Yeah. We use the client dot. We can use the same model as before, which is GPT-4 mini. And then we can set this message to optimize message because we didn't change the message. And now you are setting this temperature, which is something you can set a value between 0.1 to 1. So by setting it to a low value, it means it will reduce the randomness, or it will reduce the creativity of the model, or actually, yeah, it will produce more focused and consistent outputs throughout the chat. And you can set the max token limits as well. So what max token limits does is it will define the number of output tokens. I think Vinso has talked about tokens and how tokenization works. So like that, you can set the tokens here. And so the model knows the output should have the maximum amount of 300 tokens. So when it comes to a model like GPT-4 or mini, you can actually you don't have to set this that much, but it depends on the use case. If you want to the point answers, you need to set a max token limit. But for me, actually, one of the most important part is to manage the pricing levels. So for an example, GPT 4.5, which was released recently, has 150 USD per million pricing. So that's a really large number. So if you want to manage these models cost effectiveness, you need to specifically set a good max token limit. So you need to understand how you are going to set this, and so try this out by changing this number. So let's start with a very simple one. So I'm going to again print this one. And inside here, I'm going to use response item, and I'm going to print this one. Okay, as you can see now, this is a really small one. So when the token limit hits 30, the output stop. So let's keep it to 300. So once upon a time, in a village so small, lived a brave little explorer named Mia, who was tall. So we do have the rhyming parts, right? Bright, night, tall, grove. We have that one. That's what we mentioned in this system message. So let's change this one a little bit. Make it to 6 or 7, like that. Okay, now you got something again. And this time, it's not as same as the previous one we got, actually. What was the one we got? Okay. So in this one, there will be some differences when you run this model again and again, with the change of the temperature levels. So you can test this out very clearly in here. You can send the message and set the temperature levels and see how it works again and again. And it will show that each response has a difference compared to the previous one. And it has a lot of randomness. It's more focused on creating a more diverse and creative output compared to the ones with lower temperature levels. Okay. So again, if you have any questions, you can ask in the chat right now, because I'm going to next part is about chat streaming. Okay. Does anyone have any questions? Okay. Okay. So let's talk about chat streaming then. So as you can see, every response I got was generated instantly. Not instantly. The output came to my screen instantly. So it took about, now it's taking 6.1 seconds to get the first one, the first response here, the Brave, and also this one. Everything came to the client at the same time. So it took 6 seconds. So for an example, if you are using ChatGPT, as you know, whenever you prompt something, you get the output as soon as it starts. So that is what OpenAI calls the chat streaming. So you can actually set this very simply. So I'm just going to create a new chat here. So I'm going to name it stream. You can again name it whatever you want, but I'm just going to do it here because it's easy to refer again and again. You are using the same function, same create function, when you are using the same model. You can actually use O1 mini or anything like that as well. So in here, if you have the model, if you have paid for subscription, you have the model available to you. You can use it here with your OpenAI key. Use this optimized message, and yeah, let's use this temperature as well. Temperature 0.5. And here we are adding something called stream. Stream equal true, which means now we are enabling the stream chat feature. So in this one, you can't just print it out like this. You need to go through the docs, and you can actually find it in the documentations. You need to in here, you can actually see it here. You can go through the documentation, and yeah, I don't see any. Okay, in here you can see different ways that you can use in chat text generation. You can find that how they have defined this one. You have store function, you have these things. So let me just somewhere around here you should be able to find how you can set the yes it anyway somewhere around here you can in the docs just yes there you go. I searched it before, and because I found it, so this is actually we are inside the OpenAI API assistant API, but like this you need to use this data thing and get the message out of this one. So you need to create a for loop. You have text chunks in stream. The stream is the output that we are getting and saving here. Stream, and if you don't need that one, it will content equal chunk dot choices have the same thing, and then you need to get the data and context. I'm not sure why I'm getting this right now, but yeah, let's go ahead with this one and see how it works. Print content, and you need to add an end here as something like this, because otherwise you can't see how it actually. Yeah, now as you can see, with like 1 or 2 seconds we got the initial output. So that's actually really important when it comes to user experience. You should be able to give the user something as soon as possible, because there are situations, again, if there are some situations users would like to have the output at once, but most of our normal use cases, it is better to give them the first response and show them that this is working, and we are generating the response. Okay, so just like that, test text streaming part is also done. But for me, I'm planning on doing something else here. So let me just store this response to something. I'm going to initiate a array, not an array, a variable here, and yeah, I'm going to complete response equal. This should work. Let me run this again. And then yeah. Okay, what I just did was there's some small issue somewhere. Let me see. Did this? Yeah, okay, we got it. There's a type error somewhere. It's you can figure it out later. So now I have saved this whole response as a string or something like in my variable. So what I'm now going to do is I want an answer from you. So what I'm going to do is and generate an image for this story. So in order to generate a story, you need to again prompt something to a image model. So the image model that we are going to use is called DALL-E, DALLE 3, DALL-E 3, and you need to summarize this one. So another use case that we use OpenAI API or whatever the large language models is for text summarization. So when you have something large like this, you need to summarize it to a very low level, very less amount of words. So I'm going to create a small message that I'm going to again send. So for an example, we use this one. We use the optimized message to create a new role to system and told the system that you are a creative content writer, creative story writer. But now I'm going to create the same thing and tell them that you are a summary writer. So you are a summary who is good at summarizing pieces of text. So, and also I'm going to use the same variable like in here, and send it as the content, and I'm going to save it. Okay. So in the next step, what you have to do is again create a new variable or new request to get the summary of this above point. So in here, I'm going to call it response summary. Yeah, just give me 1 second. So again, I'm going to follow the same steps here as well. So I'm going to define the model before and then I'm going to send the message as a summary message. Now I want an answer for this one. So basically, we talked about setting temperature parameter and max token length. So when it comes to summarizing a text, what do you think the temperature should be? And what do you think the max token output should be? So should the temperature be like something that has a really high value, like 0.9, or should it be something that has a low value? So it will get a consistent answer. What do you think? Can I get uh, anything in the chat? Anyone who has an idea what is the, how much should we keep the values to? Okay, so okay, let's not waste in time. So I'm going to keep the temperature to something low because this should be something consistent, and max total limit to somewhere around 200. So we know that it's going to be smaller. So let's keep it to 100 actually. In here, if you can actually mention, give the summary and the words, you can mention these kind of things for the system message and send it. Okay, so now we are sending it. Okay, now I actually got it, but let's print it. And in here you have the choices part again to make sure that you only print the part that you need. System summary choices, and so Timmy, a braille video exposure, then find his way home. Okay, so I talked about making this an image response. So I'm going to mention you are a text summarizer. I'm going to add here gives image generation prompts. Okay, so now I'm updating that one again, and I'm sending this again, and I'm writing this again. Team, a brave expensive. No. So now I have this response. So this is the one I'm going to create the image of. So when it comes to image generation, you need a few things. So let me just just to make this easy, I'm going to copy this one image. So in the next one, in order to handle these requests, you need to use below, because that's the library that we need. And then again, we need to yeah, not like this actually. Yeah, let's import requests first, because we are going to need that one, and we need to import below as well. Yeah. And then we are going to from IO import. Let's see. Okay, everything is fine. Let's go to the image generation part. So in this one also, it's the same thing. Let's use the same one, response client. But in here now, as you can see, we are using not chat. In the previous one, we used client.chat. Now we are using client.image and generate image. Okay, images dot generate. And now again, the same thing. We are going to send the prompt, which is the image prompt. And then we are going to define a size. Let me just copy this one. It's actually really easy. Now we are going to define a size, in which size we need this image, and we are going to define the model that we are going to use, and also quality standard and the style. So you can actually define these things in OpenAI documentations when it comes to not sure how am I missing all these things. Okay, in this one actually image generation. Sorry about that one. That's the wrong API references. So in this one, you can see what are the models that are available, and what are the size, what are the qualities, what are the standard, what is the standard quality. You can see all these differences. Everything is available in the OpenAI platform documentations. So the one I couldn't find, the first one is this one, how this works. So this is also here, the text generation part. Okay, so just like this, I'm going to send the request and get an image URL. So what OpenAI does is it returns an image URL as the response. So as the response, this is the response that I'm getting in their data array, in the 0th index, you get the URL. So actually, before this one, let me print the response again, like before, so you can understand. This will actually take few seconds than the previous one. Okay, so we got the image. This in the text editor. Okay, so we got the data image in base64 JSON and device prompt. This is the prompt that we used, and they are adding their parts as well, and the URL. This is the image URL. So in order to handle this URL, you need to use this one. I'm going to use it in here, image URL, and then I'm going to download this image and show it to you. So in order to do that, you need to use response, the library that I mentioned previously. Image, yeah, it's the image response. Again, feel free to name this any way you want, but do it in a way that you can remember after a few minutes, because you know how it is when it comes to adding the URL, not variables. So then I'm going to use fill part here as well. Image dot open. I'm going to open the image that we are downloading. So yes, we will get the image, and I need to send the image response. So okay, this should work, and then the image here. Okay, so we do have this image now. So this actually depends. So it took about 9 and 14 seconds. That means close to 23 seconds to get the image up and running. So let me just copy this one and paste this on here and rerun it again, so you can see how much time it will actually take to get the whole image generation done. Okay, now we have a different image. So just like that, it took about 16 seconds. So it's not that bad. I mean, you can get an image generated in a really, I mean, this is not really the state of the art at the moment, but 5-6 months ago, we didn't, that was on the top level of image generation. And now we have other things like Flux API that does this one a whole lot better. I think you have seen this one. Yeah, anyway. Okay, so I think with that one, we only have one part we need to cover. So we covered chat completion, chat streaming, image generation, and now I'm going to do the image analysis part as well, which means, so GPT 3.5, if I can remember correctly, could not, it did not have any vision capabilities, but GPT 4.0 has vision capabilities, which means you can send an image and get a response. So what we did with DALL-E was we send the text and got the image, and now with GPT 4.0, I'm going to send the image and get the description. So let me just in here, yeah, let's start a small function here. I'm going to send the same image URL because it's easy. Yeah, same thing, response. So I'm here using this one, chat completion, because I'm getting the output as a chat. So client dot chat dot completion dot field. So same steps, model. Let's use a GPT 4.0 Not sure whether Mini has vision capabilities. We'll try it next time. And in the message, let's have this one. So I have this one here somewhere. So in here, describe this image in detail. That is the system type and image URL as the image URL. So this is basically what I copied from text generation. In here, analyzing image, you have this one same here. Like this, I just used it, and I'm sending this image as the image URL and getting the response. And I'm just going to mention tokens here. Okay, and I'm going to return the response. Choices like before message dot content. So this is the function that's going to let me just on this one. You can run whatever image URL that you're passing here. So I haven't actually passed the same image URL yet. So you can just analyze function here, and you can add the image URL whatever you want. So you can either add what's the image URL we got. It's the image URL. As you can see, that's basically bad naming. You should actually try to name something else. So I'm going to pass the image URL and get the request. Okay, that was let's use Mini just to be sure. What's the what is it? Okay, so here I'm getting an error timeout while downloading. Okay. So download error එකක්. So that means let's actually we need to download the image and add the local path, I guess. Or else I can actually we have the image URL here. So let me try something new. Print image URL. Okay, that's the thing. We don't have the image URL somewhere, so that's why we are getting that error. Okay, let's forget about that one for a while. So I'm going to just go to here. I'm going to pixels and use whatever the image that comes first or second, maybe. Okay, this actually will work. Okay, let's click this one. I'm just going to get an image and run it somehow. Open image in a new tab. This should work. I'm going to copy the URL. Pass it. I really do hope this works. Okay, it's working. As you can see, this image showcases a prominent building featuring striking clock tower and all that, brown bricks, everything that's mentioned in here. You can see it here. So the previous error I got was I'm getting this image, but I'm not saving it locally and sending it again. And I think the OpenAI somehow disposes the URL that they're generating image, maybe. But now, as you can see, it basically works somehow. Okay, so I think with that, we have come to the end of today's hands-on part. So if you have any questions, you can ask about it. I'll push this with the changes. Right, sure. With this, now you have all the content you need. If you want to go through this again, nothing. please go through this one. Please go through the documentation. Everything is there. And yeah. So, do you guys have any questions about the hands-on part or the part we talked about? Now now chat is open actually. You can ask any question you have in the chat. Okay, so if you guys don't have any questions, I think we can wrap up the session here. Thanks you for joining. I think there are a few announcements about the upcoming initial round as well. Also, you can take over.
Okay, and that was an enlightening session. A huge thank you to Winiska Jivandara and Kaviru Hapwarachi for their time, expertise, and invaluable insights into the world of large language models and OpenAI API. Your passion and knowledge have made a significant impact on all of us today. Next, before we wrap up, I would like to invite Kaviru Hapwarachi, the Vice Chair of IEEE CSUCSC, to brief us on the upcoming hackathon.
Okay, thank you again, Hafsa. So if you can go to the next slide. Okay, so we have some hints about how we are going to structure this year's initial round. So we will be providing questions about classification and one-time series question with a natural language processing question that's kind of based on what we did today and maybe something more, and then a statistical question. So as of now, our plan is to start our initial round on 8th March at 9 a.m. on the Saturday, and have set the code submission deadline to 9th March. That means you have about close to 36 hours to do the code submission. After that, you have to document what you did during the hackathon for each problem and submit the document after that one as well. So with that, I think those are the basic announcement that I have for the initial round for the participants. And if you have any questions related to this session or the Intellihack workshop, Intellihack initial round, you can ask any of organizing committee members in the delegates WhatsApp group. We will be opening registrations tomorrow, so you and your team can register for the initial round. So when it comes to this one, actually, we will release the delegate booklet tomorrow with the registration links as well. Yeah, thank you guys.
Okay, and so before we wrap up, shall we all take a moment to capture this experience? So I would like to invite everyone to turn on their cameras for a quick group photo. So if everyone could turn on their cameras. So do we have participants? Okay. All right, then on the count of 1, 2, and 3. Okay. So, as it was said by our vice chair, so registrations are opening on March 3rd, 2025. So, this is your chance to take on real world AI challenge and collaborate with like-minded people and showcase your machine learning skills on a competitive stage. So, stay tuned for more details and get ready to be a part of something incredible. And also, you can stay connected with us by scan the QR code and where you can get updates regarding Intellihack 5.0 and stay up to date. So I can give you guys some time. And I hope everyone has scanned. If whoever wants to would have scanned the QR code. And with that, then we conclude today's session. A heartfelt thank you to our speakers for their expertise and to all of you enthusiastic participants. We hope this session has sparked some new ideas and perspective for you, for all of y'all. So until next time, then good night, everyone. Have a nice day ahead.
Yes, we will be sharing the recording in about 3-4 days.